Here we have an ASUS laptop that came in for no power. We already disassembled the board, and let's see what's wrong with this one, if the fault compares with other ASUS laptops that we've worked on before. We're gonna start by measuring next to the DC connector. You see that we have one MOSFET here, and where's the other one? Where's the other MOSFET? Back of the board. We need to flip the board, and we have one right next to the current sense resistor. And we're gonna put the meter in diode mode, measure the drain on this MOSFET, and of course we have a short. We have a short circuit on the drain of this MOSFET. What does that mean? It means that we have a short somewhere on the board. And how are we gonna find where the short is coming from? We're gonna inject voltage at the drain of the MOSFET, and then we're gonna monitor the board under a thermal camera and see what gets hot. A shorted component usually gets hot. A lot of times the CPU itself gets hot, and we have to figure out what's making the CPU hot. Usually V-core MOSFETs or anything in the V-core circuit can cause the CPU to get hot, and it doesn't really mean that the CPU is bad, even though the CPU gets hot. Right now, we're gonna inject voltage and monitor the board under a thermal camera. All right, so let's see. Inject voltage. And amps being drawn right now is 2.42. What is getting hot on the board? And I do not see anything obvious. Whatever white or yellow you're seeing is just a reflection from shiny surfaces. And you can see how they go back to blue if I tilt the camera. I do not see anything hot. I did see something hot right here. I mean, I'm able to differentiate between a shiny surface and a hot component, and this only comes with working with thermal cameras every day. Watch. I'm gonna inject voltage. And note how this area is getting warm. Right here. And one more time. See? The area is getting warm, but heat is not coming from this side of the board because heat is diffused. It barely shows. So what we need to do is we need to flip the board and see what's in this area. Let's flip the board. Right now what I need to do is I need to inject voltage on the back of the board. We can inject voltage at the current sense resistor. I'm gonna lay the board down, and then we're gonna monitor the board from the surface here and see what's getting hot. The heat that we saw on the back is coming from this area and not from the V-core circuit or the CPU. So we're gonna have to see what's here. Most likely a capacitor. So let's inject voltage at the current sense resistor and see what happens. Right there, you see it? Right here. Okay, thank you very much, thermal camera. You did your part, and heat is coming from right over here. I did not pinpoint the component using my tweezers, but that's okay. Let's use our atomizer. We're gonna spray Rosen Flux on top, and then we inject voltage again and see where flux melts first. I mean, right now, to be honest, it looks like this capacitor is the problem because I do see a slight line. Let me see if we can increase brightness. It does not look good. I see a line here. So that may be our problem. Okay, so I think we have enough Rosen Flux. And now we're gonna apply voltage again and see where flux melts. And I have a very strong reason to believe that this component is the problem. This one right here. But let's see. One, two, and three. See? The component is generating just a tiny bit of heat, so it's not very apparent, but look at this. You can tell the discoloration of that component compared to the one next to it with rosin flux. So this one is covered with rosin flux, and we still see rosin flux on top, but this one, rosin flux, melted. Not by much because heat is very minimal, but you can tell. Somebody was asking in the last video, the Gigabyte 3090 repair, he said, can we use rosin flux to detect a short circuit on the MOSFET? And I said no, because heat is very minimal. Rosin flux is not going to melt. You need a good thermal camera to be able to detect the slightest heat. Now, if you have the UNI-T thermal camera, the UNI-T 260B that you purchased from our shop with the macro lens, it will be perfect to pinpoint the component because of the macro lens. I do not have one on my bench. I'm still using the FLIR A60, and I do not see a reason why I would waste opening one if I already have a thermal camera. There are 101 ways to figure out which component is short into ground, but the thermal cam is the best way to figure out short circuit. Let's remove this. See, if you have a lot of heat, that's what you would see. That's how rosin flux would melt if you have a lot of heat, but this cap is generating just a tiny bit of heat. And let's keep the cap here because some may ask, you did not test meter in continuity mode, and the cap should not be continuous if measured. But it is, because the cap is bad. And if we look here, the cap is a size 805. You can find those caps, 805 and 1206, on our website. Those are very commonly used on ASUS laptops. Let's grab one. Let's replace that cap, just like that. Done. The job is done. And not even a bulldozer can remove that cap the way it's soldered now. You can try. Now this cap is rated for 60 volts. I do not know if the original is rated for 60 volts or less, but 60 volts is most definitely better than whatever is on the board right now. Let's go to diode mode and measure for a short. Awesome. We are reading 0.41 voltage drop. We have a ground here, and we have 0.41 voltage drop. That's amazing. Board is fixed. That's it. Now, I only wish Big Boss was still here so he can reassemble, but what can you do? I have to do it myself because he already left. Today is Saturday, and tomorrow is Sunday, and Monday is a holiday here in the US. So let me take a few minutes and I'll be back. I took a few minutes to reassemble the motherboard. I did not connect all the cables, but just the major ones. I connected the LCD cable, I connected the keyboard cable, and I put on the fan and heatsink. As you can see, it's not screwed in. I just connected the fans. And all we have to do, I did not even connect the battery, but I just want to see if it turns on. If it turned on, the problem is fixed. The job is done. I do not think there's anything else I need to connect to this board. I connected everything that we need. Let's connect the cable and hope nothing is gonna smoke or blow up. Okay? I do see the light. I do see the orange light. That's a very good indication that the laptop is working. Okay, so how are we gonna do this? Let's open the screen. I do not want the motherboard to fall out and the hinges are not screwed in. But we do see the orange light. Press the power button. And nothing is happening because I do not think that I have the power button cable connected. So I connected everything except for the most important cable, the power button cable. It's only one tiny flex cable, and it's located It's located right over here. That tiny flex cable, it's not connected. Let's do it. The cable want to play games? No problem. No problem. It's a gaming laptop and we can play games. Okay. One more time. Plug the cable. And we're going to press on the power button. And right there, you can see the lights on the keyboard. And we have to wait right there. Laptop is fixed. It's booting up to Windows. And before the name pops up on the screen and viewer starts to complain, how come you're showing the customer's name? Let me close the screen. We're going to end the video right here. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe, and we'll do something else in the next video.